Have you ever tried to imagine a new color? If you haven't tried it, you should try it, and you'll realize that it seems impossible. But it just so happens that there are many other animals that can see other colors that we can't. Many animals see in many other different ways that we don't know about. Some are able to see a wide range of color, and some can only see in black and white. Today we'll be talking about what different animals see and how they perceive color. Since this is a broad and complex subject, I'm only going to talk about 3 organisms. I'm going to talk about a dog, us, and a shrimp. This may seem like a weird combination, but all 3 see things very differently. So first, I'll talk about the dog. Many people think dogs only see in black and white, but this actually isn't true. Dogs are actually what's called dichromatic, which means they have 2 color receptors functioning. So, or cones is what they're called. They can see yellow and blue. This is similar to someone that is red-green colorblind. They can't distinguish between red, yellow, and green. They only see it as one color, which is yellow. And they also can't distinguish between blue and purple. They just see it as blue. They also have a different, this is their spectrum and this is our spectrum. They also have a different, what's called brightness discrimination, which means it's the ability to differentiate between different shades. According to Andres Peter, the Weber fraction, which is how they calculate brightness discrimination, calculates dogs as a 0.22 and humans as a 0.11. This means that their color discrimination is 2 times worse than ours. So what we see as 2 different shades that are really close, they just see as 1 shade. Though dogs see differently, they don't have that huge of a difference compared to us. This is what I was talking about the shades. They only see a few, and we see different. So just like dogs have 2 cones, humans have 3 cones. Our 3 different cones help us see red, green, and blue. Stephanie Papas from Life Science says we have 5 to 7 million of these different cones. Having 3 different types of cones help us differentiate between colors. Since light is a wavelength, our cones detect different wavelengths. Molecular expression says a wavelength of 430 nanometers activates blue color pigment, letting us see blue. At 550 nanometers, we see green, and at 600 nanometers, we see red. And according to Life Science, 64% of our cones respond strongly to red light, a third respond to green, and the other 2% respond strongly to blue light. And humans usually think like we have the best like anatomy, because we're like top dogs. But actually there are many other animals that beat us significantly in the vision department. And one animal is called the Mantis shrimp. And it looks like that. They have a completely different way of seeing color. They have what's called a compound eye, which is made of thousands of small units that each detect light differently, according to Elise Andrew. There's a midband or central strip right there that's special because that's where all their photoreceptors are, and that's how they see color. And they actually have 12 cones, whereas we only have 3. So they can see a wider range of the color spectrum than we can. They can even see infrared and ultralight, ultraviolet. For example, the rock mantis shrimp has 6 photoreceptors dedicated to the UV part of the color spectrum. And each one detects a different wavelength. Ed Young says that this is the most complex UV detecting system found in nature. But although they can see more than we can, their scientists discovered that they're actually not that good at differentiating between similar shades. According to Popular Science, Hanny Thowen, a doctoral research student, did an experiment to see if its extra photoreceptors helped it to pick up different shades. And what she found was they actually have a really hard time when the colors get close. She had it trained to detect a specific color, and then she would test it and give it 2 lights, one being the color it was trained to recognize, and a whole different color. And it found that 80% of the time, the shrimp chose the color that it was trained to see. However, when the shades got closer in color, its accuracy dropped to 50%, which is like as good as if it was guessing. So it's a working theory as to why this is, but they say that instead of paying attention to detail, the shrimp just scans its environment quickly to determine between, like, if there's a predator or food or friend. This is how they've adapted to see things. So even though they have a complex vision capacity, we beat them in seeing detail. There are many different ways that animals perceive color, and this is due to evolution. Some animals survive better with a specific part of their vision being adapted, just like humans pay attention more to detail, and the mantis shrimp pays attention to color in flashes. This helps it to survive quickly. No organism should assume that it has a better vision, because their vision is unique to them, to helping them survive. And we're still discovering things about vision and how it helps us to survive.
So Neil, what did you think?
So I liked your opener and how you stated your central idea that different organisms have different perspectives in the world due to the way that they see color. You laid out your points very clearly and gave us a good guideline of where you're going to go with it and what animals you're specifically going to talk about. The visual aids are very effective in describing your points. Maybe one improvement that I would suggest is to read less from your cards. Maybe not look down too much. Look around at the audience more eye contact so you can relate to them. The subject overall is very interesting, so you had my attention the whole way. And maybe you got a little bit technical in some areas so that we didn't really understand the science behind it. Not all of us here are bio or physics majors, so we don't understand how light bends and stuff like that. But overall, it was really nice, and I enjoyed it.
All right, thank you. I thought you had an interesting rhetorical question at the beginning, and the visualization that you came up with, trying to get us to visualize something, was kind of worked pretty well at getting us involved in the subject. You have a very clear identification of the topic. The phrasing of the purpose statement is a little bit awkward, but we know generally where you're headed there, so I thought that that was fine. During the presentation, you did a few things to justify why you're talking about this. I like that idea. And there's an excellent setup of what the supporting content's going to be. I thought you did a good job on that. The definitional material was fine. You know, the dichromatic vision of the dogs, for instance, versus humans, versus our shrimp that you're going to be talking about. I thought that was an interesting piece of information. You define what that is. The visuals that you had for the most part were very solid. I'd agree with Neil on that. The thing that I think was maybe missing was the explanation about the cones and how they help us see, you know, exactly what does a, you know, what do the cones look like, how do they work in the eye, you know, that kind of thing. And, you know, we have 3 different types. The dogs have 2 different types. There's a little bit of explanation about that. And then, you know, the shrimp that you mentioned has the 12 different types. That sounds like it's pretty dramatic. That would be something that would be, if we could visualize that a little bit, that would be helpful in the eyes. Now, I did think that when you showed us the image of the eye of the shrimp, for instance, we could see that there's definitely something distinctive about the way their eyes look, and probably, therefore, about the way they work. But we're kind of like outside of that. We don't really have that. I mean, unless you'd taken a biology class or a physiology class recently, most of us would probably have a very vague recollection of how our sight works. And I hear people say things like that all the time. Well, how do they know what a dog can see, or, you know, something like that? And I'm going, well, I know that there's technical stuff there that would explain this, and that's kind of the stuff that's not quite in your speech, although the description that you have of the spectrums, the shading, I thought that was all excellent. You did a very good job visualizing that for us. And I appreciated each one of those slides giving us that distinction to help us kind of see the way the animal, the dogs are different than us, and to see, at least get a sense of how the shrimp, for instance, is going to be able to pick up different kinds of things. But also contrasting some of the advantages that other animals might have when it comes to distinctness of shapes, for instance, or shading that you talked about, and detail kinds of things. I thought that was interesting. That's, of course, hard to visualize to some degree, but the idea that it is important, I think, was nicely explained. I'm going to agree with Neil about the delivery. There's a little bit more reading than you want, and you need to kind of look around a little bit more, use more of those cones, so that you're engaging us a bit more. But I thought that there was a very nice transition between the supporting points at one point. Like I said, when you got to that third point, there's a nice transition phrase that you have there that's exactly the kind of thing that you'd want to have between the other points as well. So when you watch your video back, you probably will be able to remember because you have it in your notes. But when you watch it back, I think you'll notice how effective it is at moving from one subject to the other and doing so in a clever way. At the end of the speech, you did a pretty good job summarizing why we ought to be listening to that, and I appreciated that as well. All right, thank you.